If I could have everybody's attention once again, real quick, if we just finish up our chatter, get your greasy pizza hands into back on your plates, and hey. So I just want to say, like, thanks again for coming. First talk was great. The second talk's going to be great. But again, I'm always looking for speakers. And if you even have like maybe an idea about a talk or you're not sure about something you want to talk about, reach out to me and let's chit chat about it. And I can help you work towards an idea, or I can tell you it's a stinker, which I'm not going to tell you it's a stinker. But I definitely want to hear from you. I want to get your voice heard, and I want to get everyone in this room to talk at one of these events over the next year. With that, we're going to hand it over to our next speaker. Let's give it up for Len.
All right, thanks for, thanks for coming. My name is Lin. I work at Wolfram Research. So for those of you who are not familiar, we create Mathematica and also Wolfram Alpha. So the team I work on is actually implementing the Mathematica notebook interface in the browser. So that's why React comes into the picture. But similar to what Bagani said initially, so the talk that I'm going to give, it's not something that we use in production because concurrent React is still in a very kind of nascent kind of stage. I wonder if any of you guys actually use that in production. Oh, that's cool. That's adventurous. Right. So maybe you can correct me if I said something wrong. All right. So that's only my personal interest that I look into it. So that's why I call it a study notes. So let's see what we're going to talk about. All right. So the kind of the takeaway I would like to have you guys have is, so they just get a kind of a cultural understanding of what React concurrent mode is, and then why we will need that. And then we'll look into its implementation because, well, the code tells you everything. The kind of the version that I will be showing today is fetched this Monday from the master branch. So it's pretty new. So it should be up to date. And then I'm hoping that by going through the code, you construct a mental model of how this React concurrent mode works. And then with that, then you can see some new possibilities that you can use with this concurrent mode, as well as some caveats. All right, so a great talk that gives an overview of the idea of concurrent mode is given by this guy, Dan, from the React core team. So the idea is, I'll show some. Okay. Is it a little bit small? Okay. All right, so he basically has a demo app here, which when you start typing, so the input text doesn't actually have anything to do with those graphs. But then the graph will become more complicated when your input gets longer. So the idea is that you have a lot of re-rendering that's going on when you're typing. The problem is because the graph gets more complicated, it takes more time to get render. And as we all know, JavaScript JS engine is a single event loop model. So which means that if you take more time in rendering, it's actually blocking all the user interactions. So that's when you start to feel the stuttering, when you start to type, so bad user experience. So the usual way that we tackle that is by limiting how much we render. So we debounce. So if the user type too frequently, then we will choose to only render when it settles. But of course, then you're trading off between the liveness of the data and the responsiveness of your web application. So asynchronous mode, if you enable that, it will actually try to it doesn't block the whole rendering, but it will try to coordinate between the user interaction and the background kind of rendering. So it will render for a while, and then you back to the browser. So then the user will get a kind of chance to interact. Okay, that might be a little bit abstract, so let's bring that idea down to some code snippet. Oh, do you only get that far? Okay. Can you guys see? Well, maybe if you guys cannot see, just move over here. That's sorry. Oh, like this. Oh, good, great, nice, great tip. Right. So the idea is like, say, if you have a lot of works, and then if you're rendering, just think of it as like a lot of rendering tasks. Then what you do currently in React, it's basically doing this looping, this work looping. It's just a synchronous loop. So then it will trying to see if there are any remaining works to do. Fetch one, do that, and then keep going. Right? But that's blocking the whole JavaScript engine execution. We already know how to solve that. It's not rocket science. So we have set timeout, right? So that's how we deal with that. We're trying to have a delay that it's matching the frame rate, so we don't lose any frames, right? So then we will do some work, and then we do a set timeout, so that we get a chance for other tasks to proceed. Okay. And conceptually, that is basically what React Concurrent is doing. Even though, of course, that's very simplified, because for React, first, it needs to know what works are more important than the others. So that's one thing. And also, it doesn't have a fixed set of works. But then you have a lot of incoming works, right? Because the user keep interacting and the data keep coming in. So then you have a lot of new works that flow in. So we'll see how React deal with that. Okay. So I like to share this paragraph because I think that summarizes React's position on doing this kind of scheduling. So let me just read that out. Some popular libraries implement the push approach, where computations are performed when the new data is available. React, however, sticks to the pull approach, where computations can be delayed until necessary. So what it basically says is React is trying to do more things. It's trying to coordinate between your web application and other tasks that the browser needs to do. So it thinks it's in a unique position to try to schedule all these things. So it's not a dumb framework where it just trying to, so you just give it the data and then ask it to render something, and then it does that for you. Instead, it was trying to hold on to the work and then only perform that work at the right time. Okay? So in other words, the whole concept of concurrent mode is that it has a much better scheduling. Okay, and we also have this from the official documentation sites. If something is off screen, we can delay any logic related to it. If data is arriving faster than the frame rate, we can coalesce and batch updates, blah, blah, blah. So again, it's trying to reason why it thinks it's in a unique position to do these decisions for you. And but then after all these really nice kind of descriptions of what React's trying to do, and then it says, to be clear, we're not taking advantage of this right now. Well, that's because we are not really enabling the concurrent mode yet. But if we are, then we can scratch this line. Okay, so just again, a high-level description. So React, it works in two stages: the render stage and the commit stage. The render stage is not to be confused with the render lifecycle. You can think of render stage as stages that don't involve any side effects. It doesn't try to commit to the DOM. If we use the usual virtual DOM kind of concept, that is when it's working with the virtual DOM. So it doesn't really interact with the DOM at that moment. So anything is idempotent. So you can actually run these things for multiple times, but the ultimate outcome would be the same. So previously, this render stage is synchronous. And by the way, for the render stage, you can think of life cycles such as should component update and component will update and render, these kind of life cycles. And then for the commit stage, that is when it actually puts the updates into the DOM. And for the life cycle, the corresponding life cycles would be component did update, component did mount, and for things like get snapshots, I don't remember that name of the life cycle. So the only change if you enable the concurrent mode is the render stage will become asynchronous. That is when it can decide when to perform works for you. So it doesn't necessarily block the whole JavaScript engine execution. Okay, so all these kind of high-level description is basically saying that the concurrent mode is a way to better schedule different tasks. Okay, so how do you enable concurrent mode? There's a very nice short article that Ken Dotz puts online. But basically, you will need to download a special build because concurrent mode is still in experimental mode. So it doesn't automatically come with the current release. So you have to download that special build. And then previously, we're all familiar with this, right, this line. If you use React DOM, that's the API that you call. You directly call the static method on the React DOM object. So React DOM.render, then you put in the app that you will need to render it. So with the new concurrent mode, what you do is you first need to create a root. So that's the API that you will be calling. So you call create root. And once you get back the root, then you call the render method on that root. Okay. So that is the only thing that you need to do. Download a special node and then change a build and then change the API that you are calling for your React DOM step. So 2 lines of change, then you have enabled your concurrent mode. Okay. Well, but then hopefully after the talk, you realize that it might not be a good idea to just go and do that in your production. Okay. All right, so let's look at the code. So React actually uses what they call the feature flag to decide how to enable or disable certain features. They have an experimental tag that is specifically assigned to the concurrent mode APIs. So if you trace that back into at the React level, there are 4 APIs that you can use. So we're not going to go into details about these, but they are basically some components and also some React hooks that you can use the new scheduling kind of improvement. Okay, and at the React DOM level, it enables several different things. I'm not going to go into those unstable stuff. But then you remember that we just saw that you need to use the create root. So that is, if you use the create root, then you create one that has the concurrent mode enabled. And there's another new one, it's called create blocking root. So this one, you can think of it as the middle stage between the concurrent mode and the current synchronous mode. It's called the blocking mode. It's supposed to be a migration path for you. So you start from the current state, and then you want to migrate to this blocking root, see if your app actually breaks. If not, then you can move on to the create root API. Okay. So that is the high level kind of API exposures if you want this to be enabled. Okay, so again, that's just circling back to now we have 3 different routes. Previously, when you call the React DOM.render, it actually creates this legacy route for you. And then the batch route is what we call the blocking route just now. And then the concurrent route is when you call the create route API. So if we look at the legacy routes implementation, this is the React DOM render API that we are all familiar with. But ultimately, it's really just calling this kind of constructor to create a route, rendering route with the legacy routes tag kind of passed to it so that it knows it's a legacy route. Likewise, the batch route is just having the blocking route tag that gets passed in when you create and calling this constructor. And then the concurrent route, again, it's not special. It's just calling into the constructor with this specific tag. Okay. Right, and then once you, and then behind the scene, when they actually create these kind of routes, what it does is it does things in a library that they call the fiber. So fiber is React's reconciliation and scheduling functionality. Okay. So when you create a component, when you create a route, it actually creates a fiber route. And then for the fiber route, you can think of it as a mimic of your component tree. So every component in the tree that you create will have a corresponding fiber attached to it. So the individual fiber node actually represents a single work that can be done by the scheduler. Okay. Yeah, it's a little bit abstract. The fiber is actually the core part of React. So if you want to understand React really extensively, that is the thing that you need to look into. But for us here, when you call those constructors, ultimately it's going to just trying to create a fiber route based on the mode that you pass in. So you can see that for the concurrent route, it's really just a little bit of a bit manipulation to have both the concurrent mode, the blocking mode, and the strict mode enabled. And if you're trying the middle route, then it's only going to enable the blocking mode and the strict mode. And right now, if you do React DOM.render, that's what you get, no mode. Okay. So this actually, again, outlines a migration path. So what you want is first, if you really want to try the concurrent functionality, the first thing you want to do when you get home today is to enable the strict mode. Okay. So what strict mode does, it will warn you about all these unstable APIs that you're using. If you're using component will update, I think, some things like that, which they call the unsafe stuff, then it will actually warn you because the concurrent mode doesn't like these. And if everything goes well with the strict mode, then you can turn on using the create blocking route in your React DOM API calling. And then for that, that will also trying to, what this does is it will actually trying to batch multiple updates together. So right now, when you have a new work, it will just go through the work loop and then pick one by one those work and then just run them together. But then if you have a batch mode, then it will actually trying to see if multiple updates can be combined together and then run that. And if you feel happy about the blocking mode being enabled, then you can switch to the concurrent mode. Okay. And I want to open up this feature comparison graph that they have, because I'm hoping that this will, when we get through the source code, that will explain a lot of things. So again, we go back to the 3 different modes that we have: legacy mode, blocking mode, and concurrent mode. You can see that if you enable concurrent mode, then you can have a lot of features open up for you. I'm not going to go through this list, but the things that I'm going to talk about is cooperative multitasking and automatic batching of multiple set states, as well as priority-based rendering and interruptible pre-rendering. So hopefully by going through the source code, you understand how that's implemented. All right, so let's go do that. So automatic batching, how is that achieved? The idea is very simple. Remember that we said that every fiber node can be regarded as a single work unit, right? So what React does, or this fiber scheduler does, is it attach a expiration time to each individual fiber work. So the expiration time, if the expiration time is smaller, that means the task is more immediate or more urgent. So it needs to be run first. Okay. So that is the function called compute expiration time for fiber. So we can see that, well, if you are using what you're using now, then you're not getting all these. You're just getting, every task will have the same expiration time, which means that they will be run in a first in, first out basis. So there's nothing special. Okay. And this is for the, so if you look at the kind of the bit comparison here, then if this mode doesn't have the concurrent mode bit enabled, which means that because it's not a no mode, right? So then it must be the blocking mode. So in the blocking mode, you do have two different expiration time. One is the synchronous expiration time. The other one is the batched version. So that's why they call that, if you enable this mode, you will get the batch behavior. Right. Okay, and then keeps going. And then that is the concurrent mode. If you have that enabled, it will actually trying to accommodate for different priorities. So these are all the priorities that you can specify today. You have immediate priority, which probably is associated with user interactions. You have user blocking priority. And then you can see the normal priority and the low priority are actually the same thing right now. They just have a placeholder there. And then if your app is not doing anything, it has an idle priority. Okay, so let's go into a little bit more detail about how expiration time is computed. So one interesting thing here is you can see that for this high priority expiration time here, it actually uses a flag depth, which means that if you're in a development mode, you actually get a higher priority time. But why is that? Because it wants you to notice the data problem or the rendering performance problem in your application. So they set up a higher expiration time so that if your application is blocking user interactions, it becomes more obvious. But then if now you decided, well, this is what I need to push to production, then it helps you out by setting a lower expiration time so that it gets executed faster by the scheduler. So interesting bit there. Okay, so if we look into the compute expiration bucket function, this is how the batching is done. There isn't any magic. It's a ceiling function with a given precision. So this precision is calculated by the bucket size that you pass in divided by unit size. So unit size is usually 10 in the code. And the bucket size is this batch size number that you pass in. So we all know how ceiling works, right? Because it just truncates the time by the given precision. So if your bucket size, if your bucket size is 250, and then you divide it by 10, so it's 25. What that means is anything that happens within the 25 millisecond will be bundled together because you will get the same expiration time. That is how the batching is done, right? Anything that happens within this chunk of time is going to get the same expiration time. So then it will be treated equally by the scheduler. Okay. So again, this explains how they have different priority when it comes to different rendering, and then also how the automatic batching is done. Right? So it's really simple. Just truncate everything within a certain time period. Okay. And then, oh yeah, I just want to show this thing. So again, if we look into the actual work loop here, and then you will see that if you're using the current mode, then everything is just going to be done synchronously. And then also then probably maybe an interesting bit here is this condition here is actually detecting if you're using the legacy context API. And that actually explains why you don't really want to do that. It's very performance-wise, it's really bad. It's trying to, if you're using the legacy context, then you have no choice but to run everything synchronously. Okay. Okay, so we talk about how the priority is set. Maybe you are curious if there is an API that lets you specify priority. Right? For example, if you are putting in a button callback function, an on-click function, can you specify the priority? So I found this API here, but you can see it's labeled as unstable. So it's probably not a good idea to use it, but you can if you want. So this unstable API allow you to pass in a priority level. Of course, you only can pass in those 5 different priority levels that we talked about. And there's some test cases that they use in the test suites, which shows how you can use that. But basically, you can use it in callback, any callback that you use in your application. Okay, so we talk about automatic batching and priority-based rendering. How about the fancy word multitasking and interruptible pre-rendering? Well, that goes back to our super simplified example. So if you look at the actual work loop here, if you are in a synchronous mode, that's what it does. It goes through your fiber roots and then traverse the tree, pick out the next work that needs to be done, feed that into this giant while loop, and then keep running until there isn't any work to do. So that is the current behavior. But if you have the concurrent mode enabled, it looks very similar. It just has one extra condition here. It will trying to see if it should yield back to the browser. Okay. So that is what they call the interruptible rendering. And that's all that's to it. Let's look into a little more details in the implementation for that. So for deciding whether they need to yield back to the browser, that's the call that they're using. But you can actually only look at this part. Okay, and that's all they're doing. They basically calculate the current time, and then the deadline is actually a time that is computed from the current time plus a yield interval. So if you pass your deadline for the given task, then it's time to yield back to the browser. The reason I show this chunk of code here, because I find it really interesting. Have you guys ever seen this API called navigator.scheduling.isInputPending? I haven't, so that's why I got curious. It's actually a RFC from Facebook, the first browser RFC for Facebook. So what it does, so the reason I also open up this page is this is also a very interesting comparison. Right now it's in React. This is how things work. You have a long running JavaScript, and then you have some browser activity. You go back to your while loop. What we want to achieve by enabling concurrent mode is you yield more frequently. Okay, so going back to this API, so that navigator.scheduling.is input pending. So right now, if you want to know if there is any user inputs, there isn't actually an API to do that. You can have you can create a callback function, but you don't really know if there is some incoming events that is waiting to be handled, but not yet. That's what this API is doing. It will, if you use this API, it will actually tell you if there is any user inputs that is pending. So that is going back to React's philosophy that it's trying to use a pull approach. It's trying to actively work with the browser. They're trying to see if there's any incoming works. If there is, we're trying to yield back to the browser. So that's just like a fancy API that is on the horizon that might be useful. And yeah, this is just you back to our very first simple code snippet. So if the way that it used back to the browser is just calling a set timeout. So set timeout, and then if you reach a certain deadline, the U interval is 5 milliseconds. I actually don't really know why they choose 5. That seems really short. But then their whole idea, just use a set timeout, you back to the browser. Okay, yeah, so just quickly recap what we've looked at. So we look at the APIs that's currently exposed by the React concurrent mode. And then the concurrent fiber nodes, they label update works with varying expiration times. And then when they calculate the expiration times, they're actually doing work batching. And also we look at the work loop for fiber, that it's non-blocking and is trying to yield to the incoming works that has higher priorities. I do want to say that I didn't really get into the details of fiber, but if you think of this whole work loop yielding back, there's a critical detail that I never covered, is that all the works needs to be done under a certain context. So you can't really just suspend the work and then hoping to get back. You know what I mean? Like you have all the surrounding things related to the suspended work. And that is a big part of the complexity of fiber. It will actually need to remember all these surrounding contexts so that when it gets back to resume its execution, it will do things properly. So I really like this illustration of what fiber is doing. Fiber is re-implementation of the stack, specialized for React components. When they talk about the stack, they're talking about the calling stack. When you call the function, when it goes back to call another function, it actually needs to remember where they were previously so that they can go back. So you can think of fiber, the whole idea of scheduling, being able to suspend work as a re-implementation of a interruptible calling stack. So conceptually, that works really well for me. And then there are some new challenges and possibilities that come with the concurrent mode. I'll just quickly go over that. So one challenge is the reason that you can't just enable concurrent mode like today is that, remember that we said the render phase actually can be suspended and resume. The implication of that is the render phase can actually be called multiple times. And that goes to why they label all these life cycles as unsafe. If you look at those life cycles that they don't want you to use again, component will mount. The problem of these, I mean, it's not problem of the life cycles per se, but it's how people using it. A lot of times you will try to fetch data in component will mount. But then the problem is now the component will mount lifecycle might be called multiple times. Do you really want to reach out to the network and fetching data multiple times while your work is being interrupted? Probably not. And these like unsafe life cycles, they all have the problems that they are supposed to be idempotent. They're not supposed to have any side effects, but then they are in practice being used by people. And then another one is there isn't an incremental adoption. When you enable the mode, everything is in this concurrent mode. You can have multiple React DOM routes, but that's usually not a good idea, right? So again, the migration path is just enable strict mode and then trying to migrate to blocking mode and then see if concurrent mode works for you. And then I'm not going to talk about the new possibilities. I think I'm running out of time. But then the idea is that with this better scheduler, with the ability to suspend, resume work at view, it actually exposes a lot of possibilities for you to streamline your, say, data fetching, right, and multiple different workflows. I do have some like links here and then examples that you can look at. Okay, so yep, we just talked about some the challenges of concurrent mode, and then we didn't cover the use of suspense for how you fetching data, and then there are also 3 other new APIs, as you saw, looking at the React API. But these things are all just the application of this better scheduler. There's not much to talk about it, actually. Right, so I do put in some resources. I understand that my talk is a little bit kind of maybe too detail oriented, but then if you really want to actually look at the APIs, like how, as a user's perspective, how you want to use them, this link actually links to an actual workshop where it shows all the exercises that you can follow along to trying to understand that. And then I highly recommend Andrew Clark's note on Fiber. That was where my quote was from. It's a very concise and conceptual kind of description of the core of React. And of course, the source code is available, so go look at it. Yep, so that wraps up my talk. Thanks. Sure.
Anybody have any questions?
Go ahead.
I'm sorry, this isn't a question, but for other folks, if this was hard to follow, just he's absolutely right. Understanding the reconciler helps a ton. Dan Abramov did like a 90-minute video at some point last year. If you search Dan Abramov reconciler deep dive, you can find it. Just because like there's certain issues with concurrent mode, like tearing, that you now have to care about, and like just the stage that was set by Fiber it helps understand these kind of problems. Thank you for the talk. It was awesome.
Yep, thanks.
Anybody else? If you don't follow Dan Abramov, by the way, he's very good, especially if you use React. Let's give it up for Lynn.
Thanks.